Can you turn a 650 CFM carburetor into a 500 CFM carburetor with just a booster change? Well, we're going to find out today. If we look at that from just the perspective of changing the booster over, the possibility in doing that is very strong, and I'm going to tell you exactly the reason why. First, let me show you a cutout of some of the channels that are in there. Now, this is a 850 CFM carburetor that I just cut up, but one thing to notice is if you look at the boosters here, these are the primary boosters where they go in. You've got the jets. Jet is here that goes into the fuel bowl. If you look at these channel sizes here and the amount of fuel that's the ability to flow into the booster, at it. But all of these channel sizes so far that we've looked at on the front of the carburetor, when we milled this down to take a look at the transfer slots, idle mixture screws, where the vacuum ports are referenced, the channel that came from the accelerator pump, all that was the same size. So what that tells me is that what Edelbrock has done is that they have tried to or change the CFM rating of those carburetors by the venturi size, the throttle bore size, and what size booster that goes in there. So let me do this really quick. I'm going to go ahead and knock the 500 apart because we're going to take the primary and secondary booster out of here. That's going to go into the 650, and I want to show you some differences between the two. On my website, I have all the part numbers, or most of them anyway, of all of the boosters. When you look at the top side of the booster, you have to remove the air horn assembly to look at it, but it will give you a part number of the booster of what comes in those carburetors. But you can go download that list if you want, and that way if you've got boosters separately, like I've got boosters laying all over the place here, I can quickly take a look at it and go, okay, that came out of a 650, and then we can match them up, make sure we get a left-right booster, and then we're good to go. Same on the secondary side. You can take a look at it, part numbers right there, and determine it. So we know we've got different primary and secondary boosters in here. Now, the interesting thing is the way this meters fuel and air through here. When you look at the 500, it's a little bit different. So you've got another air reference there, and your fuel only out of the secondary booster on the 650. So it's going to behave a little bit differently. Now, the good news is because those boosters are, well, the body size, physical size of here where it bolts into it, same with on the primary booster, they're all the same. The boosters will physically fit into there. It's just how everything's configured, how many pickups there has on the fuel, what type of air bleeds, the size on the bleeds, and what their channel restrictions are, or the restrictors are that are in there. So we know those will fit in there just fine. It's going to be interesting to see how it all works out. One more little detail here when we look at that, let me just get these all separated again, is when we take a look at the some basic information in here. I'll leave this up on the screen too so you guys can take a look at it. When you look at the primary bore size on these, they're both the same on the 500 and 650, inch and 7/16. It's the secondary size that's a little bit larger, plus coupled with the reduction in size or the reduction of airflow that's going to go through the 500 because the booster is physically larger. That's where you get the different CFM rating in it. Now, another curious thing is you've got a smaller nozzle in the 500 versus the 650, and if we remember back to those videos, we talked about that. That doesn't mean there's less fuel. They're both delivering the same amount of fuel. The accelerator pump size in all of these carburetors is exactly identical. The nozzle is the time delivery of time of that shot into the engine. So when you have a larger number, it is a larger orifice size on the nozzle, which means it'll deliver the fuel pump shot quicker. So they slow it down on the 500, a little bit faster on the 650. Rod, jet, some are very different, both use an orange step-up spring. So by thinking about it, I think what I would like to do here is, we'll change the primary and secondary booster. We will also make a nozzle change, so I'll pull the 28 out of that one, pull the 31 out, and put the 28 into the 650. And then what we will do is I'm going to jet it exactly the same as it is on the factory calibration, and then we'll begin tuning from there. Now, the GMC truck, I have had a 500 on that truck before. I can look back at my notes. I don't want to do that, but we'll just watch the AFR and see what tuning changes we need to make. But the real curiosity is, can we swap those back and forth? I think the biggest thing here and all that is if you had the ability to find sets of boosters. Now, I'm going to mention this offhandedly. I don't want you to go out there and make any rash decisions on it, but I have right now currently a full set of 650 boosters and a full set of 800 boosters on the website if you want to try this in your own carburetor. So if you've got a 500 and you want to put the 800 boosters in it, I've got a set on the website if you'd like to do that. But I've got lots of cores here that I've torn down, so I've got tons of sets of boosters laying around. And I typically don't do that. I typically don't offer those, but I've had so many people say, well, you can just put the 650 boosters into whatever, or the 500s or the 800s in. We'll see. But I think what this will allow us to do is, and potentially we'll do this down the road, is potentially we can get some a little bit more fuel economy out of that 650. So we're going to have to do that on a separate video because that's a lot of tuning. We'd have to tune the 650 for more fuel economy than performance, what it is now, and then kind of go back to back and see which one performed better on how much miles per gallon we gained or stayed the same, whatever. Video for the future. Let me do this. Let me go ahead and knock the 650 apart. We'll get all the 500 boosters in. We'll change the jets and rods, and we'll get that all settled, and then we'll go from there. Here's a set of boosters out of a 650. Now, I haven't knocked that one apart yet, but I have these separately so we can take a look at them. So here is the 650 booster that is out of there. When you compare it to the 500, it's certainly much different on its size. It's much more restrictive, wider, bigger. So that will choke down the venturi size and how much air can flow through there. But what it also does is it helps increase the signal strength, because typically you have a high vacuum on that, but you're looking for that signal coming from the intake manifold and the pressure drop underneath the booster that occurs for fuel to start being pulled through the system, through the channel, up through the booster, and then down into the system. Couple interesting things, though, when you look at that. So that's 500, that's 650. Here's a booster out of an 800. Now, a lot of times folks will go, I've looked and seen an 800 booster. They're so much smaller or restrictive in the size of the venturi. They're almost like a 500 booster. And that's fairly accurate. The main body is pretty close to the same. Height is just a slight difference in it, but it's when you look down on the inside, you've got a much bigger opening on the 800 and much smaller on the 500. So that's the primary differences between all three. So if we look at them like this, 500, 650, 800, those are the three booster sizes in the AVS2 carburetor. We've got our Frankenstein 650 built with the 500 boosters in it. One little detail that I did do is I did leave the silver step-up springs in there for the time being. That's an easy change anyway. I did change over the nozzle and then everything else. Jetted it back towards a 500. So exactly what the 500 is from the factory. We'll start with the base cal and then kind of go from there. So now that we got all that sorted out, let me go get this installed on the truck, and then yeah, we'll just start going through the process, see what the AFR looks like, and see how this thing looks. We're all hooked up, AVS2's installed. Couple of things here. I went ahead and started it up, kind of set idle speed. Mixture was off just a little bit, so I trimmed that up a bit. I did already take it for a drive. It is really, 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 really rich. I forgot to take the camera with me, but I'll overlay the O2 sensor so you can kind of see what the AFR was reading. And yeah, it's very, very rich all the way through power and cruise mode. So I think what I'm going to do is we'll look at, we've got the sheet started so we remember what we do here. Base calibration for the 500 is where we're at, and I think that's a good place to start. I don't know that I would jump to the 650 and start tuning from there. We're going to tune to the booster, not to the CFM of that carburetor. We're going to see how it works. So since we are so rich in the cruise and power mode, we just follow the tuning chart. Here's your base calibration, here's your cruise mode, here's your power mode. If we want to go lean in the cruise mode and lean in the power mode, we just drop over here. The next calibration point is number 2, and I can already tell right now that's a rod and jet change. So remember we said make small steps, see if it helps out. I have a feeling that's still going to be very rich, but I'm going to stick to my guns here and make those small steps. I think that's the smartest way to do it. So let me do that. Hopefully, I've got to go and do a car show tomorrow morning just to monkey around first thing in the morning and blow off a little bit of steam. But let me go ahead and do that first, and then we'll either hop back in the truck tonight and take it for a spin, see how well that did, and if we have to go any leaner, or we'll just meet you on the road tomorrow on the way to the car show. Okay, she idles pretty good, okay at 14.0, 14.2, whatever, but we are still running really, really rich, so I'll show that to you. Little quick drive here. Just feathering into the throttle. Still rich. Very, very rich. Now when I back out of it, just to cruise, it's still way, way too rich. So that's what I was afraid of. We just didn't take enough fuel out of it. That's okay. We'll take the next step. I guess while we're here with it, let's see how she does a burnout. All right, let's see how she does. Not bad. All right, let's take some more fuel out of her. Well, two things are going to happen here. I'm running out of daylight, so I think what I'll do is I'll make the next rod and jet change, but I think I'm going to do what I normally don't do and make a really big jump. So we're at number 2. I know we've got to go way, way leaner on both cruise and power mode. I'm just jumping right down here to number 4. So number 4, yeah, rod and jet tells me what they are. Let me go dig those out real quick. I'm going to make that rod and jet change tonight, and then tomorrow morning will be a little bit cooler. I think we're in the low 80s or upper 80s. Yeah, we're in the lower 80s right now at 8 o'clock at night. So I think that's what I'll do is I'll go ahead and make that rod and jet change tonight. And then on the morning on the way to the car show, it'll be a little bit cooler, and we'll see how it runs. So we'll come back here in a few hours. Okay, made a rod and jet change the next morning. Little odd here. Right now we're in drive. Idle's good at where it's at RPM wise. We're good on the AFR, but I still think we're a little on the rich side. So we'll take her for a little cruise here. This road's nice because I can kind of go back and forth a little bit from about 40 miles per hour up to about 65 and try a couple of different things. So light throttle. That's our cruise AFR-ish. So probably still running on primaries. Maybe a little bit on the secondary. This mile per hour. And right at 55. So yeah, we are still for sure on the fat side. works pretty good. We did take a lot of fuel out of it, so the problem is we're off the tuning chart now, so everything I make here is going to be a mathematical calculation to figure out where we need to go to take fuel out. So I still think we're going to take it out of the cruise RPM. Vacuum's at 20. Let's see when we get into the step-up spring. See how far it dropped down? Step-up spring release, dumped all that fuel. I guess let me think about it for a little bit, but it's a warm day here. It's 9:30, it's already about 85 degrees, and heading to a little car show in Byhalia, just down the road from me. We'll go run by that really quick, but then we'll go make a probably just a rod change, see if we can change the way that looks. So here is our challenge with this. We are at number 4 on the tuning chart, so we are at the end of what would come in a calibration kit. So no problem there, but when you get to that point and you still need to do some, richening if it's on the top side or leaning where it's at now, it's generally because either one, you've chosen the wrong carburetor for the application, which we've certainly done here. That thing's a bit of a Frankenstein with the 500 CFM boosters in the front and back, so it is running a little bit differently because of certainly how that thing meters fuel. What we would do here in this case, like I mentioned when we were driving, is we look at number 4, we're on a 65 and a 47. So let me do this. Let's move into the benchtop real quick because I want to put a set of calipers on there just to remind you what that looks like and then what steps we're going to take to change that. Okay, so here is what our challenge is. 65/47. Now, let me get a set of calipers out because I want to measure a metering rod. Let me find one here. This one's decent. Now remember, you've got 2 steps on this metering rod, right? You've got this down here where when the metering rod jets here is compressed, you've got engine vacuum that's holding the step-up spring down, so you are down on the fatter part of the rod, okay? When vacuum releases or drops in the engine, releases the spring, the rod comes up, and then now you're on the smaller part of the rod into the jet. So you flow more fuel. More restrictive, less restrictive down here at the bottom. So we did a couple of videos on step or metering rods, talk about how they're designed and all that. So you can go check that video out if you want. But what I want to do is I'm going to put a set of calipers on here so I can show you, and then we're going to pick another metering rod for this application. So let's take the bigger part of it here. Like I say, when the spring release or is completely compressed because there's high engine vacuum, you're up here on this. So this is a 75/47, so we should be at 75, 74/5, close enough. So now when you get down here on the small part, it should be that 47, and we're bang on 47. So what we need to do, our challenge with this is a 65/47. So in all reality, I want to make a small change here because I'm not going to talk about the math on this one. We'll do this on a later date in another video because it's kind of complicated, but it helps you when you're in these situations. So let's try to find a rod that is around 67. That'll be thicker on the fat part, so it will reduce our fuel at that light throttle. And then let's see if we can get really bigger on the secondary side, on the secondary number. I think I know which one I'm going to use, but let's take a look at it. Now, I've got these charts on the Muscle Car Solution Carbs website. You can download this for free. I'd highly suggest you do that. There's a ton of free resources on there. I even put build sheets of the truck so you know all the parts that I'm using on it, so you can take a look at that as well too. But that is a 65/47. So this is the current rod we're using right now. Our challenge is to find one that's a little fatter. So let's go down to the 67, and then we need to find a number that's larger than 47. So 40, 37, 49, little bit, not bad. 67.55. I kind of like that. We were really rich. 10 on that release side. So I think that was going to do. We just need to lean it out just a little bit. So let's do that. Let's find this 1463 rod, and then we'll put those in the truck and see what happens. All right, I found 2 of those rods. Let's throw the calipers on there really quick. So what were we, 55 bang on, and then what were we, 67 on the fat side. 67 bang on. Just verify. Guys, I apologize too. It's almost 90 degrees here, so if you're hot, turn a fan on or something. Don't worry about the noise. I'll be fine. 55, 67. Okay, so we know our metering rods match. All right, now we got that sorted out. Let's get these in and see how much of a difference that made on the AFR. Yeah, just did a little bit of driving. It doesn't look too bad, actually, but I need to look at that a little bit closer on the AFR to see where we're at. So what we're looking for is cruise with high vacuum, meaning we know that we're in the step-up spring is still down. We're not into the small part of the metering rod. So we need to look at the AFR there, and then we need to look at it under load with the vacuum gauge open or the vacuum gauge down low enough that it opens up the step-up spring and allows it to be on the narrower part of the metering rod. So let's take a look at it. It looked pretty good a minute ago when I was driving, but let's see how it looks as we go through here. That's not bad. So vacuum dropped a little bit. Let's hold her steady. Need to get on a little bit more open road, but that AFR is not bad. Turn around and we'll take a look at it and see what it looks like under load, where we're going a little bit more aggressively on the throttle, and right now we're about 15 inches of vacuum, so we're bouncing a little bit on the rod. Okay, you've seen this before, so let's watch the AFR and see how we are aggressive on the throttle on a burnout and see what happens with it. That's not bad. That is not bad at all. That was pretty good. I saw 12.5, 12.9, wide open throttle. Not bad at all. Not bad at all. I'm gonna cruise on this tune for a while, see what happens, but we're cruising at 14.0. That's not bad. It's got pretty decent low end throttle response. Got good torque. I thought we were gonna lose more on that top end, but I'd have to get the draggy in here to hook it up to see what we are on time for a 1,000-foot run or whatever. But that's pretty good cruise AFR at 55. I'm not upset with that at all. Light load. 13 on the vacuum gauge. Yeah, I think we found our tune. We're pretty doggone close to it. Let's give it some gas here. Get it across the tracks. Low vacuum, 12.5. Bang on. On the diesel, you're always going to show a lot more fuel. You're still metering a lot of fuel through there, so you got to give it a few seconds for it to kind of stabilize out, engine vacuum to come back, and we're right where we want to be. I'm not upset with that at all. Sheesh, still 80, high 80s here. So what did we learn today? Well, did that work? I'm going to call it a success. Now, there are some little details here that I just didn't quite like. The burnout we did just a minute or so ago in the video, that hesitation when going from no load, not on the gas at all, to stabbing a wide open throttle, slight hesitation. We could correct that potentially. Maybe the secondary door, we need to adjust that a little bit. Now remember, we just played with the primary side on this. I didn't touch the secondaries at all. And we achieved that AFR that we had of that, 12.5, 12.9 at wide open throttle, which I liked a lot. And then our cruise, I would probably try to still lean that out just a hair more. I don't know that I would make a jet change. I might, well, it might be a jet change at this point. I don't think the rod would be a good place to go with that because we'd have to go leaner on both sides. On the big end of the rod and then on the smaller diameter, we'd have to go lean on both. So anyway, it was a good little exercise, and I didn't mind working through that. So yeah, if you could do it, you can make that work. If you're just it was just a cruiser, just a driver, you could get all that sorted out. Total time on that for making these adjustments, driving, which is the big part, and then any of the changes we made on the carburetor, probably got about an hour and a half-ish of driving, and then probably another hour because it's so scorching hot here to do the carb work under the engine, because I had to let it cool off a little bit. Like I said, it's 90 degrees here. So anyway, can it be done? Yes. The problem is finding a set of boosters to make those changes. But in this instance, where we tried this booster change, I would say that was reasonably successful. I think I might be able to tweak that just a little bit more. Again, get rid of that off-idle, wide open throttle hesitation, and then I think we're down on power just a little bit. So I may play with it a little bit more. I may just go right back to the 650 calibration on here because it was so good, and then go from there. But anyway, that won't stay on the engine full time. It was just a test, and I think it turned out pretty good. So anyway, if you got any questions down below on the tuning side of it, anything on what we did, anything on rod and jets, I won't get too much into the math on that here. Again, that's a whole other video, and we'll do that at some other time. But because it gets a little complicated, and I need some good, nice, clean, air-conditioned air to do that in, so my brain doesn't overheat. So anyway, again, check out the resources I've got for free on the Muscle Car Solutions Carbs website. Geez, that's way too long. And you can down all those for free and check out everything else I've got there. So hopefully that gave you a little bit of insight on that. And yeah, we'll catch you guys on the next one. We'll see you.